All right, Algebra Honors. This is our Unit 7, Unit on Polynomials, and this is Day 5. We're going to be factoring trinomials today, and we're actually going to be factoring trinomials in our next lesson. Today is Part 1, where a equals 1. A is our leading coefficient, and I'll remind you of what that is in a moment. So, just a quick warm-up review. If we think about the word factors, we're thinking about things that can be multiplied together to give us a product. Okay, so our example might be factors 2 and 3. When I multiply them together, I get 6. So I can think of 6, I can break it up into factors. If I break it up into 2 and 3, I can multiply 2 times 3 again to get 6. Okay, so before we start factoring, which is really undoing multiplication, we are going to just remember how to multiply two binomials together. I'm going to use FOIL, okay? So I'm just going to say x times x is x squared. Outer is going to be x times 12, which is 12x. Inner is negative 3x. And last is negative 36. And then, of course, I want to combine like terms. So I'm going to have x squared plus 9x minus 36. So if I multiply these two binomials together, I'm going to get a trinomial as my answer. These two, x plus 5 times x minus 10, I'm going to multiply first, x squared, outer, negative 10x, inner, positive 5x, and last, negative 50. So if I simplify that, that's x squared minus 5x minus 50. So you can see some generalizations as you multiply, and it doesn't matter which method you're using. But if you're multiplying two binomials, you're going to see that x plus p times x plus q, so pretend we have p and q instead of numbers, you're going to see that you have x squared plus your coefficient of x is going to be p plus q. So negative 3 plus 12 is really 9, right? So that's going to be my middle term, my 9x. And then your last term is just the last two numbers, negative 3 times 12. So we're going to kind of use some of these generalizations and patterns to break a trinomial apart into different factors. All right. So in today's notes, we're going to be thinking about this form of a trinomial, ax squared plus bx plus c. That's our standard form. And if our a is 1, then that's what we're talking about today. A equals 1, okay? The leading coefficient is the coefficient before your x squared in these trinomials. Okay, so I'm going to say that a x squared, the coefficient before x squared is a, the coefficient before just x is b, and then my constant is c. So if I'm looking at x squared plus 8x plus 15, my leading coefficient is 1, because there's an invisible 1 there. The coefficient before my x term or my middle term, that coefficient is 8, and my constant is 15. Okay, so we're going to do a lot with our a and our b and our c in different trinomials, but first let's take a look. We do have to show you visual representations because some standardized testing is going to use just visual representations. You might not even get numbers in the beginning. Also, that visual representation is helpful sometimes to really get a good solid concept of what we're doing when we're multiplying. All right, so I'm going to be using big boxes. Can you see my big box? And bars and little squares. Okay, a big box is x squared. The way I'm demonstrating today, my shaded box rather is my x squared. My x is going to be a bar. So I know that it is, on my x squared, I know one length is x and the other length is x. X times x is x squared, right? On my bar, one length is just 1 because I have one of them, but the other length is x. It's that variable that I don't know. So the area inside this big shaded box is x squared. The area inside here is x. And then just a constant 1, we're going to do it as a little box. So I'm shading for now just to make points about the difference between my big box x squared and my little box, which is 1. And I'm only using positives for today. So sometimes in representations, you're going to see that shaded is negative, but that is not the case for me right now. This is just so you can kind of see what I'm working with. All right, so I'm going to go back first to multiplying binomials using the box method instead of using FOIL. So if I do this, I can put x plus 1 along the side, and I can put x plus 2 along the top. Those are my two binomials, right? When I multiply x times x, I get x squared. X times 2, I get 2x. 1 times x, I get x, and 1 times 2, I get 2. Right? So, and I know I can actually combine my like terms, and I know the answer here would be x squared plus 3x plus 2. So we're going to use this idea. That's really what's happening here. Remember I said a bar is x, this is x, and this is 1. So this is really x plus 1 in pictures instead of in numbers. And at the top I have x, that bar, and then I have plus 1. So really that's 2, right? I have x plus 2 along the top. If I multiply a bar x times a bar x, it's going to give me this whole area, see? And I would fill that in. You know x times x is x squared, that's my area. Its one length is x, and now the other length is x. Okay, also, if I multiply 1, just one single constant number, times x, I'm going to have 1x. See, I have a bar, right? 1 times x. So it's very much like what we did with our box method. If I multiply the constant 1 times 2 constants, I'm going to end up with, sorry, I'm sliding all over here, 1 times 2, or 1 times 1, we can look at it that way, and also 1 times 1, right? And then I also have 1x here times my 2 constants. So I have 1x for that constant, and then I have x times 1, so I have another x here. Okay, so looking at my pictures, I can actually give my algebraic answer by looking at my pictures. I have 1x squared, right? And then 1, 2, 3, I have 3 x's. Remember, those big bars are just x's. And then I have 1, 2. I have 2 single constants there. Does this match what we got before when we did it algebraically? Yes, and that's what it should do. So, very honestly, the pictorial representation is actually more difficult for me sometimes. It just takes me sitting down and really thinking about the pictures, and so a lot of times I might, if it's a multiple choice test or something, I might look at the answers and see which answers match what I know the answer should be. So the pictures just take some practice figuring out how to show your work with those pictures. All right, so here I need to identify the two binomials that I multiplied together to get this product. So remember, it's just like our box method, we are multiplying the things on the outside, and the answer is what we have inside, right? So my answer is 1, 2, I have 2x squareds, right? 1, 2, 3, I have 3 x's, and then I have one single guy right there. Okay, so I got to figure out, I had to multiply x times something to get x squared. Well, I had to multiply x times x to get x squared, right? Here I got x squared also, so I must have multiplied x times x right there. X times x is x squared. X times what gives me just one x? Well, a single. All right, so I can see that I multiplied here. I had x, I had 2 x's plus 1 single. And here I had 1x plus 1 single. See how that works? So let's see if algebraically, if we get that same answer. Okay, just for kicks. X plus 1 times 2x plus 1. I'm going to use FOIL and see if I get the same answer. X times 2x is 2x squared. Outer is 1x, inner is 2x, so it's 3x. And then 1 times 1 is 1. Okay, and it's the same thing. So we can do these types of problems using pictures only if we need to. And sometimes that's really helpful to get a super solid understanding. So let's try this guy. This is my answer. So I can see that I have x squared. I must have multiplied x, right, times x to get x squared. Okay, and here I just have a single x, so I must have multiplied 1 times x, and I must have multiplied 1 times x, and I must have multiplied 1 times x, right? Here, I need to end up with x, so I'm going to do 1 times x and 1 times x. And I just want to make sure my remaining stuff makes sense. So I had 1 times 1, yes. 1 times 1, yes. 1 times 1, yes. Now my lower guy, this guy, right? I'm going to say 1 times 1 is 1, 1 times 1 is 1, and 1 times 1 is 1. So my final answer is one single x squared in there, the big dark guy. 1, 2, 3, 4, 5. I have 5 x's, and I have 6 1s. I want to make sure this makes sense, right? It looks like I had x plus 2 here, and x plus 1, 2, 3. I have x plus 3 here. So I believe I multiplied x plus 2 times x plus 3 and got x squared plus 5x plus 6. Let's just check it out. X plus 2 times x plus 3. I'm going to use FOIL. X times x is x squared. Outer is 3x, inner is 2x. 3 and 2 is 5. And then last is 2 times 3, so it's 6. And thank goodness that matched and worked out. So pictorial representations, fun for all. And I know that you need to have a basic understanding of those pictorial representations, but you won't see a whole lot of them, I don't think. Anyway, let's flip our page over and see if we can factor out the greatest common factor. Okay, so greatest common factor is just one single term, basically. It's going to be a monomial. It's going to be a polynomial with one term. So I'm looking at 18x minus 6, and I want to know what goes into both of those. So this particular section, you just have to kind of think about, what are the factors of 18? 1 times 18, 2 times 9, 3 times 6, right? 6. I can see that 6 also is going to go into this negative 6. I'm going to pull a 6 out. 6 times 3x minus 1. You buy that? So I just undid distribution, just to check. 6 times 3 is 18x minus 6. When I redistributed that 6, it gives me 18x minus 6, so I got that right. 24x minus 30, I gotta think. I know 2 goes into both of those, but that's not enough. Let's try 6, okay? 6 goes into 24x, 4x times. 6 goes into 30, 5 times. Okay, some of this is a little bit of trial and error. You want to look at what your binomial, or whatever you're left with inside. This is a binomial. In this case, you want to look at whatever you've got inside and make sure you don't see any other factors you could pull out. Make sure you got everything out of there. Okay, so 6x squared plus 5x, there are no rules that say I can't pull out a variable. So that's what I'm going to do. I can pull an x out of there. So if I take 6x squared divided by x, I'm going to have 6x left over. 5x divided by x is going to be 5. And I can check again, right, by redistributing. It would be 6x squared plus 5x, so I've got that. Okay, this guy, I've got a trinomial this time, so I need to make sure whatever I take out can come out of every single term. So I have a 10 and a 5 and a 30. I normally start with my, my coefficients first. The biggest coefficient I can take from all of those is 5. So I'm going to say 5 times... Let's see, what else can I take out? I have x cubed and x squared and x. I'm also going to take an x out. I'm going to take 5x out of each one of these terms. Okay, so 10 divided by 5 is 2, and x cubed divided by x is x squared. I just took 5x out of that first term. 5x squared divided by 5x, I have 5 divided by 5 is 1, and x squared divided by x is x. And then finally, I have 30x divided by 5x. So 30 divided by 5 is 6, x divided by x is 1. All right, so I have factored out a monomial. I've factored out whatever I could from every term that was in my original expression. And if I double check, if I multiply that back out, I get 10x cubed, good. And then I get 5x squared, okay. And then I get 30x. All right. So I'm going to just take a quick look at these last 4, and then I'm going to do the rest of these notes in a different video. Okay, so notice I was able to pull out x from each of these terms, right? I'm looking for something that I can pull from each of my terms. Terms are things that are separated by plus or minus. So if I look here, I can imagine that this is really 2 terms. This is all of that minus all of that. 2 terms, right? Now I realize that inside each of my terms, I do have some adding happening, right? But here's what I want you to notice. Look, I've got x plus 2 and x plus 2 in each of those terms. Up here, I had x in each of my terms. Down here, it's just more complicated, but I have x plus 2 in each of those terms. I'm going to pull it out. So I'm going to pull it out, x plus 2. Well, if I say x times x plus 2 divided by x plus 2, I'm left with just x, right? Minus, if I have 3 times x plus 2 divided by x plus 2, it's going to be just left with 3, yeah? So how cool is that? I pulled out a binomial and I was left with a binomial. You can multiply that all out, use distributive property up here, and then use FOIL, and you will get the same product in the end. It'll be back to a trinomial, and it'll be the same trinomial for both of those. That's how you can check your work. All right, over here, I'm imagining that I really have 2 terms. This is the first term, right? Because it's just something added to something else. I can see that I'm going to pull out x minus 1. That's my factor, because x minus 1 is being multiplied times the other stuff. So I'm going to say x minus 1 here. 3x times x minus 1. If I divide that by x minus 1, I'm left with 3x. And 8 times x minus 1, if I divide it by x minus 1, I'm left with 8, positive 8. Yeah? Feel free to check if you don't believe me. Use distributive property and check it out. You'll see that you get the same trinomial either way. Okay, what can you take out of each of these? X minus 2. So let's pull out x minus 2. 2x times x minus 2 divided by x minus 2, whoops, x minus 2, is going to leave me with just 2x, right? Okay, minus, what do I do here? What do I do? Oh, wait, I know there's a 1, right? It's a 1 times x minus 2. So 1 times x minus 2 divided by x minus 2 is just 1. Okay, so I pulled x minus 2 out, and I was left with 2x, and really negative 1 there, right? So 2x minus 1 was what I was left with. All right, let's see. What am I going to take out of each of these? It's going to be 3x plus 2. That's what I'm going to take out. Don't forget you have a 1 right there, right? Plus 1 times all of that. So if I pull out 3x plus 2 from my first term, I'm left with 4x. And if I pull 3x plus 2 from my second term, I'm just left with 1. All right. So thanks for watching. I'm going to just do the rest of these notes in a second video. And hopefully it'll all start making sense or continue to make sense.